Hello everyone, welcome back. In this video we are going to learn another important concept in Java multithreading, that is callable and future in Java. So we will see with a clear explanation and practical examples. Subscribe to the channel to keep learning and growing your Java skills. So let's get started. So callable and future. So imagine you send a long running calculations to a background thread, okay? So the task finishes successfully and calculate a result. So background thread calculates a result. Now your main thread needs that result, but there is a problem. Okay, if you use Runnable, its run method, Runnable is what? Interface, right? So Runnable interface has run method and its return type is void. So this run method does not return a value. So how do we execute a task in another thread and get the result back later? Okay. So this is exactly the problem that callable and future will solve. Okay. So think like we are creating one task, okay, with the help of Runnable. Okay. And when thread is started its execution, after completing of the thread execution, after completing of execution of task, we want to get result, but with the help of Runnable, since its return type is void, we will not get a result. So this is one problem that is being solved by the callable and future. Okay. So in this video, we will understand the difference between Runnable and callable, and we will learn how background task can return values, and we will understand what a future actually represents, and see what really happens when we call the get method. And there is one important behavior of get that can accidentally make your asynchronous code wait. Okay. So we will see exactly why. Okay. So until now, we have frequently used Runnable to define task. So Runnable has run method. Okay. So Runnable is functional interface. It has run method with return type void. Okay. So its return type is void. This means a Runnable is useful when we simply want to perform some work. Okay, for example, printing data, processing something, or performing a background action. Okay, but what if our task needs to calculate and return a result? So in such cases, Runnable does not directly provide a return value from its run method, right? That is where callable become useful. Okay. So callable is another functional interface. See, callable is another functional interface. It is used to represent a task. Okay, but unlike Runnable, callable can return a value, return a result. This is return type. Okay. Here we are using generic type. So whatever type we are providing, that will be return type. Okay, so callable is generic. The type parameter represents the type of value the task will return. So for example, if callable we are calling integer, then integer will be return type, and for a string will be return type, and any custom user object, the return type will be user. So its call method returns a value. Okay, here we have call method. Okay, so call method returns a value. It can also throw checked exceptions. Okay, so this makes callable useful for asynchronous tasks that needs to produce a result. Okay, asynchronous means what? Asynchronous means so it will not wait for the output to occur. It will keep on executing the remaining lines of code. Even if in later point of time we are getting result, we can capture those results. That is asynchronous task. Okay, now we will see the difference between the Runnable and the callable. Okay, so you think like Runnable means do something. Okay, you think like in memory, do something, and callable means do something plus return something. That's it. That is the basic difference. Okay. And method wise, in runnable interface, both are functional interface. Okay. But runnable has run method, callable has call method. Run method return type is void, call method return type is value. Okay. Callable is generic. So whatever type we are providing as a generic, so that type becomes the return data type. Okay. Cannot declare checked exception in run, but it can throw exception. Okay. In call, we can have the exception. And in executor.execute, we can call this method for submitting task. In runnable, we can use both method, execute as well as submit. But here we can use submit method. Why? Because we need to have some return value. Okay. So when working with executor service, callable tasks are typically submitted using submit. So the easiest way to remember the runnable and callable is for runnable, do something, and for callable, do plus return something. Okay. So these are the basic differences between the runnable and callable. Okay. Now next is submit the task. Okay. So we have seen different ways of submitting the task. So we create an executor service. Okay. So this is what executor service. We created one executor service with pool size 2. Okay. Then we submit the task. Okay. So submit method does not directly return the integer result. Since we are in generic, we have declared integer. So submit method will not directly return the integer value. Instead, it will return future. See, future of integer. So submit method will return future of integer. Okay. Why? Because the task may still be running. That means we will not get the result just immediately after calling submit method. It might take some time, and later point of time we'll get result. So for that purpose, we use future. So future acts as a handle to an asynchronous computation. Okay, that may be completing later point of time. So this is one of the most important ideas to understand. A future is not necessarily the result itself. Okay, it represents the pending or completed outcome of the task. Okay. Now we will see the future. What is future? Okay. So a simple way to understand the future is to think of it like a claim ticket. Okay. Think of it as a claim ticket. Claim ticket means what? Imagine you give something to a service counter. Okay. Then that service counter has given you a ticket. Okay. Has given you a ticket, and that ticket is not the final item. It represents something that you can retrieve when it is ready. Okay. So future works in a similar way. So we submit a task. Okay. We submit a task using callable. Okay. Then executor will give us future. Okay. Future is like a token or a receipt. Okay. And the task may execute asynchronously. Like task is running in the background asynchronously. Okay. Then we can use that future to interact with the task outcome. For example, we can retrieve the result when it becomes available. So once result is available, we can get that result from the future. So how do we actually get the result? That is the question. So we get actual result from the future using get method. So we call get on the future. Okay, future.get, then we get the result. So if the task has completed successfully, get will return the result. Okay. So in the previous example, we have seen 10 plus 20 we were returning as part of integer. So it will return 30 as the output. Okay. But here is the important question. What happens if we call get method before the background task has finished? Since it is asynchronous, right? So it is working in the background. So it is under process and we are calling get method. In such case, what will happen? Does Java will return null? Does it throw an exception? Or does something else will happen? So this behavior is extremely important when working with future. Okay. So if the task has not completed, okay, and when we call future.get method, the calling thread waits until the result becomes available. So in whichever thread we are calling this method, and the asynchronous is in process, so this current thread in which we are calling get method, this thread will wait to complete this asynchronous operation. Once this operation is completed, then this get method will return the result, and this thread will continue the remaining line of code. Okay, so it is a kind of blocking. If the asynchronous is in a process, still we have not retrieved the result, and we are calling the get method. So in whichever thread we are calling the get method, that thread will be in blocked state for that particular period of time until we get the result, until this operation completes. Okay, so this is an important point. Okay, so we need to understand where and when we call the get. Okay, now we will see how get works. Okay, so let's visualize the flow. So main thread, we will submit task using callable. We will call the submit method. Okay, and then executor service gives the main thread as a feature, and then worker thread will execute the task. Okay, if the main thread immediately calls get while the worker is still processing, the main thread has to wait. Okay, and once the worker completes successfully and produces the result, then get method will return the result. Okay, then the main thread continues. Okay, so here what we are doing, submitting task, and we are receiving feature and calling get. It will lead to waiting of the worker thread. Okay, so this worker thread will start task, then processing, then return. Then main thread will return get value, then the remaining line of code will continue. Okay, so future gives us access to result that may become available later, and get is how we retrieve that result. Okay, potentially waiting if necessary. So this is like the flow of get method. Now we will see the flow better demonstrates the benefit of asynchronous execution. So first we submit the task. Okay, first we will submit the task. Then while the worker thread is processing, okay, the main thread can perform other independent work. Okay, so while this task is under process, main thread can perform other independent work. Okay, only when we actually need the result, we will call the get method. So we will get the result when needed. Until then, the main thread will perform some other independent work. Okay, that is not related to this task. So if the task is already completed, by then get can return immediately the result. Okay, and if not, still we have to wait for the result. So a useful principle is do not call get earlier than necessary. Okay, only when requirement comes or you want to use the result, then only call the get method. Okay, so this was like better flow for the calling get method. Okay, now there is one more method called isDone. So future also provides the isDone method. It tells us whether the task is completed or not. If it returns true, that means task is completed. Okay, so we should be careful not to create a loop that constantly call isDone. That is another important point. Okay, so isDone means the process is completed, task is completed, it will return true, or else it will return false. But we should avoid constant checking of this method isDone. Okay, because that would simply create another form of busy waiting. So the key point is that future gives us ways to observe and interact with asynchronous task completion. Okay. And now let's say what will happen if our callable fails. We have provided the task with the help of callable and we are getting some kind of exception. It is throwing an exception. So because the task is running asynchronously means it will not wait for the result. The process is happening in the background and later point of time we can get the result. So we are getting, instead of result, we are getting some exception. So that exception does not simply appear as a normal exception thrown, okay, directly from the submit call. Instead, the task failure is captured by the future. So when we call this future, we will get the exception. So the original exception from the task is available as the cause of execution exception. So this is another important reason to properly handle future.get method. Okay, it gives us both the result of successful execution as well as the task failure. So for both purpose, we can use the get method. Okay. So when we call get method, there are two important checked exceptions to understand. That is, interrupted exceptions can occur. Okay, interrupted exception can occur if the thread waiting it's get interrupted. Sorry. So waiting thread is interrupted. In that case, we'll get the interrupted exception. So a common practice when we cannot propagate the interruption is to restore the interrupt status by calling current thread dot interrupt. Okay, this one. And another is execution exception. Okay, it indicates that the asynchronous task itself has failed. Okay, so when using future, we need to think about both successful result and failure handling. Okay, now we will see the complete flow. So the complete flow is very simple. First, create a callable task. Okay, callable task will create. That is first step. Second, submit it to the executor service. Okay, so executor service will create a worker thread and provide this task to some of the worker thread and get it done. Okay. Now fourth, the task execute using a worker thread. And fifth, when we need the result, okay, when we need the result, call get on future. We should call the get method on future. We'll get the result. So callable represent the computation. Okay, future represents its outcome. So whatever outcome, it may be result, it may be exception, whatever we'll be having inside future. Okay, and get retrieves the result. So we'll get the result. So this is like complete flow for this one, from creating task to getting result. Okay, using callable. Now the next question is which one you should use, runnable and callable. So when should we use runnable and when should we use callable? That is the question. So if the task simply needs to perform some work and does not need to return a result, in such cases we should go for runnable, because return type of run method is what? Void, right? So if we want to perform some action or something in which we don't want any kind of return result, then we'll go for runnable interface. Okay. And if the task needs to return some value, okay, some value we need to return, in such case we'll go for the callable. Okay, so we submit the callable to an executor service. Submit is the method for submitting a task to an executor service, and executor service will provide this task to the some of the worker thread, and that task will be completed. And once completed, we can get the result by the get method, the final output, the result. Even if we are getting exception, we can have with the future.get method. Okay, so we use that future to retrieve the result when needed. Okay, so the simplest model is runnable performs work, callable performs work and returns a value. So always remember, runnable will perform only work, whereas callable will perform work and it will return a value. Okay, and through future, with the help of future, we can get the outcome with the help of get method. Okay, so future has some limitation. Okay, so callable and future allows us to execute tasks asynchronously and get the results, but traditional future has limits. What if we want to automatically start another operations when the first task completes? Or what if we want to combine the results of multiple asynchronous tasks? Or what if we want to build an asynchronous pipeline without repeatedly blocking the current thread using get method? So for these kind of questions, more advanced asynchronous workflows are there. So Java provides a much more powerful API, and that is completable future. Okay, and that takes asynchronous programming in Java to the next level. Okay, so that's all for this video. I hope you now have a clear understanding of the runnable and callable concept in Java. Thanks for watching, and I will see you in the next video.